Hello everyone. Lesson 2 is all about frequency distributions. And the first type of distribution we're going to talk about is a frequency table. First, we're going to review a little bit about what are descriptive statistics, and then we're going to talk about tables and graphs as forms of frequency distributions. As a reminder, descriptive statistics give us a chance to summarize information about a whole set of scores with just a few numbers. Or sometimes we use visual representation such as graphs or tables. So it's a way of taking a lot of numbers and making sense of them. We are describing the data. We're not inferring anything, we're just saying what's out there. So a table or a graph, no matter what you're talking about, have the same two elements. First of all tables and graphs have a set of categories, and we call this X. So when you see X in a table or a graph, that refers to the categories. And so as I take a look over here, we have some categories: extra small, small, medium, large, extra large. These are the categories in this graph. And the other element, very important element, is the frequency. And the frequency just refers to the count for any category. So the number that are in any category. So for example, the frequency for extra small is 10. So the numbers on the left-hand side of this graph here are frequencies. What is the purpose of a frequency table? Well, it's to take some disorganized set of scores, put them in an order grouping, everyone with the same score. So we want to take this massive information and try to make it more comprehensible. So here is an example of the data that you just saw on the last slide put together as a frequency table. So let's talk about what you can see here. First of all, you are seeing the entire set of scores. And in addition to that, you can very easily see what the highest score is, what the lowest score is, and what the spread of the scores is. So let's just take a look. The highest score here is an 8. The lowest score is a 3, and the spread goes from 3 to 8. I know that. I also can look over here and see that a score of 5 is the most frequent. 3 people had a score of 5. Only one person had a score of 3. So this X represents the scores or the categories. In this case, they're numbers, so they are scores. And the F is the frequency. How often did that number come up? So there were 2 people that had a score of 7, 2 people that had a score of 6, and so on. You're going to want to make sure you really know what these numbers represent, because the X numbers are not actually numerical numbers, they're categories. A score of 3, a score of 4, a score of 5, those are categories. And on the right are the counts, the frequencies. Okay, what do you notice about this table right here? Take a moment to look at it and see. These numbers represent a data set. Let's say it's a 10-point statistics assessment exam. Just to orient you, we have the lowest score is a 4, the highest score is a 10, and the frequencies are here. So what do you notice about this table? Well, first of all, we do see that all possible values are listed. The lowest score was a 4 and the highest score was a 10, but no people had a score of 5. That doesn't matter. We still include it in this list. Also, the categories are listed in order. We list our categories from largest to smallest, the largest number at the top going down to the smallest. We do this with ordinal, interval, and ratio data because these are all ordered data. So we start with the larger number and go down to the smaller number. Nominal data are not ordered because they don't have any particular order to them. And just as a reminder, this X is not the actual set of scores. These are categories representing each possible score. So think of X as categories. Don't think of them as numbers, even though they look like numbers. This is the category of a 4. This is the category of getting a score of 5. And on the right are the number of people that got those scores. So 10 is listed once, but 2 people scored. So if we were to write all these out, we would have 2 numbered 10s, 2 scores of 10. Frequencies are added up to figure out the total number of individuals in a study. So if I were to add up all these frequencies, I would know how many people took this test. So we're going to do some practice right now, putting together some information from lesson 1 and some information from this lesson. We're going to calculate the sum of the scores, and then we're going to calculate the sum of the squared scores. What I'd like you to do is pause the computer, do this on your own, and then come back. I know it's tempting just to not do this, but you want to do this so that you get good practice. So pause, and I will be here for you. All right, so what we have here is we have an n of 20. You get that n just by adding up all of the numbers in the frequency column. Our first direction was to sum up all the scores. So what I've done is I've taken the scores that were in the grouped frequency table and I've split them out. We had 2 10s, we had 5 9s, we had 7 8s, and so on. So the first direction is to sum up all the scores, and when I do that, I get a score of 158. Our next direction was to sum up all the squared scores. I know I have to square first because of PSY. Exponents come before addition. So I have to square each score and then add them up. So I have 100 plus 100 plus 81 plus 81 plus 81. You get the picture. Plus 81 plus 81 plus 64 plus 64 plus 64 plus 64 plus 64 plus 64 plus 64. Oh my gosh, I'm getting a workout. 49 plus 49 plus 49 plus 36 plus 36 plus 16. Phew, and I'm so brilliant. I know that that number is 1288. Okay, maybe I had that number written down ahead of time. All right, the next thing we're going to talk about is something called grouped data. So sometimes we have a lot of data, just a ton of scores, and if in this case a simple table is no longer appropriate, we want to organize data, and we call this a grouped frequency table. So let's take a look. So here's a bunch of data on the right, and as you will notice, the lowest score seems to be about 51 and the highest score is in the 90s. And as we mentioned before, when you're making a table, you want to include every possible value. So this would be a very long table indeed. We just really wouldn't want to read a table like that. So instead of representing every single possible score, we put together ranges of scores. And this is a grouped data, a grouped frequency table. So the data categories don't represent individual scores anymore. They represent ranges of scores. The scores are grouped together. And we call these ranges a class interval. So let's take a look and see what this looks like. On the right-hand side, you see X. X is our categories or our scores. And all of the scores are represented from 50 to 94. But instead of listing every single score, I've listed a range of scores, which we call, again, the class interval. So we have a score of 50 to 54 and 55 to 59 and so on. The frequencies now represent the number of people that are in this class interval. So the original scores had a low of 50 to a high of 94. And I've divided, you can divide your range in several different ways. I've divided it into 9 different intervals here. 9 is digestible, 10 is good. You don't want to go over many more than 10. Each interval in this particular table is 5 points wide. So 50 to 54 represents 5 different scores. 55 to 59 represents 5 scores. They're equal. So the frequency column lists the number of individuals, again, within each class interval that happen to have that particular score. You lose some specificity. I don't know what exactly the scores are for these people anymore, but I know the range that they are in. Here are some guidelines to keep in mind when you are constructing a grouped frequency table. You want to keep your intervals to about 10. You go more than that, and then you just start to have a very long table. You can have fewer or more depending on the form, of course. Your width should be simple. So widths of 2, 5, 10, or 20 are good for the class interval. having a width of like 7 is a little bit weird. So it just makes more cognitive sense to have widths of 2, 5, 10, or 20. All intervals should be the same width. So if I have scores that have a width of 5, all of the widths should be the same. If you're using 10 width, then the interval should start with 10. So for example, 10, 20, 30, 40, 50. And the bottom score at each interval should be a multiple of the width. So that's it for now for tables. In the next video, we're going to talk about frequency graphs. See you there.